Hello. So this is the exciting and topical human-computer interaction and AI lecture. So first, let's get some terms out of the way, just so at least for this video, we are speaking the same language. Um, the term AI I'm using as a combination of underlying modeling technologies for the purpose of mimicking human cognitive tasks at some scale. Machine learning as the development of algorithms that can learn and generalize from data without explicit instructions. And the idea of human centeredness is a philosophy of making that prioritizes the human at every point in the process. Also, may be valuable to understand that AI as it isn't so much a thing as it is a collection of things, a collection of technologies that hopefully yield the mimicking human cognitive tasks aspect. And as we've talked about a lot in the other lectures, right, the focus in this course is on the human. So in this, one of my favorite comics, Dave, we're most interested in that. And what this is kind of humorously trying to suggest, right, is so far no technology has ever been found to be totally foolproof when it comes to humans. And that's true even for fully autonomous technologies. So that's our focus in this course, right? We want to enable technology, but via the user route, via making it helpful, usable, safe, those things, because ultimately all of those will drive acceptance and adoption. So just try to keep that in mind. So like I said, when we talk about AI, right, it's a group of technologies and models and different methods that are trying to make determinations, recommendations, or in some way process data. Machine learning serves an important role. So does statistical modeling, data processing, some of those things. Any statistical model or machine learning model, AI model, or cognitive model is only as good as its trained data. So we get this garbage in, garbage out aspect. This is true even with humans, right? A lot of people report how impactful traveling is as they consider their place in the world and the context of social interaction, etc. And that's largely because in terms of human interaction, our experiences are limited to our spaces where we are. So while it may not be garbage in, garbage out, it's certainly particular type of garbage in, particular type of garbage out, which may not generalize to other situations. So then we have to ask, right, do humans help or harm AI? And this has been interesting, especially since the pandemic and ChatGPT blowing up. One of the things that I noticed a lot after that was ChatGPT kind of out of the gate was like miraculous. And then within about 6 months to a year, it suddenly was not that good. And I think a similar thing happened to Microsoft's AI chatbot Tay when they released Tay onto Twitter, and with the hope that the chatbot's interactions would help it learn and drive that, and it ended up becoming like a racist Nazi very quickly. Both of those, I think, really capture the garbage in, garbage out model. So when ChatGPT was trying to rise in popularity, all of a sudden, a lot of people began to use it. So it trains on its inputs. So as more and more actual humans, just general users, started to interact with it, folks that weren't inside OpenAI or data scientists or any of these things, once actual people got a hold of it, it became stupider really quick. And that's because humans are tricky to understand and to parse, and we misspell things and we use poor grammar and different things. Um, so that's also an interesting question to ask, right? So next we're going to talk about responsible AI. So you'll hear this thrown around. You'll hear different terms, responsible AI, ethical AI, whatever. But ultimately, I picked responsible for this, but depending on what angle you're taking, you can call it something else. But realistically, I think responsible AI works. And that means what? If an AI is responsible, that should mean that it's explainable, it's interpretable. Notice those are two different things. We'll get into that. It should be ethical, legal. Obviously, a responsible AI should be responsible, and trustworthy. And we really need to ask, is it even possible to build something like this? And people will land on different sides of that debate. It's certainly a challenge when we think of there aren't a ton of humans that meet these six, uh, expectations 100% of the time. Um, so that's one of those questions, right? Is how do we make sure that our products that we're developing are good for our users, not just the society in general, Skynet stuff, but like, is it just a useful product that's going to be good for people? And how do we kind of interpret that? Because historically, if you read Weapons of Math Destruction by Cathy O'Neil, it has not been most of these things, um, and has been implemented in ways that are dubious. And I think a lot of people, if you nailed them down and said, hey, do you want a computer, not a human, to decide if people get thrown in jail? Well, no, I want a human, and those kind of aspects. Another thing with responsible AI that is important to note, right, is accountability. So there's an old quote that a computer cannot be held accountable, so therefore it should never make a management decision. And we've seen that, right? So a few years back, when Instagram CEO, there was a congressional hearing on Instagram's feeding body shaming and self-harm content to young teen girls. And so, and Instagram said they were taking care of it, all these different things. And then the CEO shows up to Congress, and I don't usually give politicians, tips of the hat, but in this instance, they built accounts of young girls and tested it before the hearing, which was incredible to really nail him down on why some of these things aren't working. But one thing that was telling, right, was the CEO at a few times said, we don't know why it's doing this, or something to that effect. That's not a direct quote, but the algorithm that serves content on Instagram was so black a box, so non-transparent, that there were some aspects of it that they couldn't seem to fix at the moment. And that should be really concerning. It's had real world impacts on some of those users, and negative, incredibly negative impacts. So if we think about that at scale, right, how many, let's say, suicides from body shaming how much of that, if that's the squeeze, how much juice do we have to get as a society? And so that's one of those questions that a lot of AI folks don't want to make, but it really is like, yes, making your AI responsible and making it meet these 6 bullets here is going to impact its efficiency, is going to impact its speed or its capability or those things. But who cares? In human society, when things are dangerous, we put barriers in place to manage that risk. So why wouldn't we do it here? Okay, so looking at explainable AI. So explainable AI, often acronymed to XAI, is a set of processes and methods that allow human users to comprehend the results of ML algorithms. And one thing I want to note, right, is explainable AI did not come from the broader human-computer interaction, human factors, engineering psychology domains. It is largely a computer science domain concerned with the creation of algorithms that can help understand other algorithms. So when we look at AI, right, we have a lot of black box algorithms. So deep learning with hidden layers and a neural network, it's right in the name, hidden layers. Or if we have really complex data modeling and transformations, that can be really hard to parse. So XAI methods are statistical methods intended to parse the inputs and outputs of the model and then capture the importance of the aspects. Essentially, it's trying to do the job of, let's see, a jury in a criminal trial. They're getting the inputs, the evidence, and then they're getting the outputs, which are whatever occurred, and they're trying to figure out the middle. They're trying to figure out, okay, with this evidence, what was the decision-making process here? So XAI methods are attempting to do that. They focus on things like prediction accuracy, traceability, decision understanding. I threw a question mark in there because one big thing with XAI methods, right, is if you needed super advanced degrees and understandings of computer science and mathematics to parse some of the complex neural networks that are out there, you need at least a college level, if not master's level, awareness of the same to interpret XAI often. So decision understanding for who, I would say. And some examples, right, are SHAP and LIME. These are different models that are out there on the explainability path there. So here's a Shapley chart as an example. And so what this is trying to do is to describe the value of a feature. So the impact of one of these variables on a model output. And so this is kind of how they look. And if you stare at this long enough, you can start to kind of understand what the chart's telling you. What's really tricky if you're not really well trained in these methods is trying to understand what to do with this, because it's not naturally intuitive. And that gets to our differences between explainability and interpretability. So explainability is there an explanation for this thing? Interpretability is, do we understand that explanation? And it's important to capture that difference there. Yeah, so we just talked about this, right? What is explainability? What about interpretability? What about trust? You know, we trust a lot of people in society when they can't explain or we can't interpret their reasonings. Let's think about, well, the Supreme Court's a great example, but a more close to home one would be like doctors, medical professionals, right? They say, we're going to put you on X medication to help this. You can ask them why it works, and they can give you an answer, but that answer is going to be highly sterilized, may not be the right word, but highly adapted to a lay person. You know, they're not going to explain the actual chemistry that's going on with that drug to make it do the things it does. But we still trust them to do that. And one of the biggest things, you know, I talked about prior, but the reason I think that we do that is societal expectations and accountability. If the doctor messes up, they are liable in many instances. So there's some measure of balance on that side. And again, we come back to a computer cannot be held accountable. So even if you have an algorithm that makes, let's say an algorithm makes a horrible decision and a bunch of people die, in whatever context, who do you sue? Or who do you throw in jail? Is it the development team of the AI? The marketing team? Maybe they pitched it in a way that it shouldn't have been used. Kind of like an aerosol can should not be used as improperly. Those kind of things. Or CEO of a company. Like, how do we do that? And that's a problem that AI needs to solve. Now, I argue that by taking back some of the explainable notions of XAI into HCI, human factors, back where the humans are, I think that we have a real role in developing methods and designs that will work for real people and have a shot at widespread adoption because of some of the things we've talked about. And that's tricky because in many instances, XAI as a discipline does not validate its assumptions about explainability. So one study, for example, showed that of 18,000 papers that they reviewed, less than 1% included actual human studies. So in that instance, I would say, who is saying these things are explainable? Because it's certainly not humans, at least not users. And we get back to that age-old adage, right, in HCI, UX, whatever, you are not the user. This applies to everybody. This applies to SMEs in a system that you're working on. This applies to developers of an algorithm. That's why we do this, is because we have learned that by showing these things to actual people, we can improve them. So then looking at human-centered AI. So this is a separate approach that's different from the XAI disciplines. I also want to note there is another, HCAI is how this would be an acronym. There's also HCXAI, Human-Centered Explainable AI. The only thing we love better than user research is acronyms. But I would say that HCXAI, which has been pushed heavily by Dr. Yupal Ehsan and some folks from that side of the fence, I think aligns fairly well with HCAI. So I don't think they're really at loggerheads or anything. But HCAI was kind of argued first by Ben Shneiderman a few years back. It puts humans at the center of AI development and design. He also recommends abandoning the levels of automation frameworks, which we see some from Sheridan's levels of automation. That's the most famous one. But also there's O'Hara's levels in what we look at in nuclear power, for example. And that's kind of a little bit of a backtrack for Dr. Shneiderman, because he was a part of that process to elevate these levels as a good framework. But the problem is a lot of folks took the levels of automation to mean that human control and automation level were on a single spectrum. So any step towards one was necessarily a step away from the other. So high levels of automation meant necessarily low levels of human control. And in the HCAI kind of work, the several papers Dr. Shneiderman put out and then his book argue that automation and human control are not two sides of a single spectrum, but instead are more characteristics that can occur in varying configurations. So here's an example of the HCAI 2x2. So you have high levels of human control or automation, And up here, we want reliable, safe, and trustworthy algorithms. He gives different examples of these things. For example, one that I really enjoyed was if the one that would fit up here in the upper right quadrant would be a, a digital camera, a modern like SLR camera. The human still has high levels of control, but there's also significant computer automation for light adjustments, different things like that happening while taking the picture. Um, but again, the human can exercise that control. Another one that would be kind of similar on a higher level of automation, but a kind of lower level of human control, could be like an elevator. We do have some control, we tell it to go up or down, but as is commonly used in every TV show at some point, right? People get stuck in elevators. That does happen, and we don't really have a lot of control of that. And so that's one area, where we might see something living in the bottom right quadrant. So now in HCAI, we also talk a lot about governance. This is how we get to accountability. And the way that it's discussed is kind of 3 levels, where each step up includes everything below. So when we look at these, right, initially we have team, organization, and industry level governance. Team governance, this is just software engineering technical practices. This is making sure you have audit trails, making sure you have good workflows, you're doing good user research, making sure you're doing your bias testing, those kind of aspects. Then within that, you are a part of an organization which should have a safety culture. So this is, you have leadership commitment to the culture, you're managing failures and near misses, you're then feeding those into internal reviews, you're adopting relevant industry standards, and kind of that aspect. And then at the top we have external reviews. So this is, and if this should not seem novel, nearly every industry in the US and probably worldwide is ran in this kind of a way. Even illicit industries, like if you were to look at like organized crime organizations, they kind of have something similar to this. It's just how humans tend to assemble organizations. And then when we get to this outside, right, this is where real accountability lives, and some of that adoption. So we have government regulations, right? Auditing firms and expectations that come with that. Insurance companies. This was the first time I'd ever heard an AI domain discussion about insurance. If you are an insurance company, how do you ensure that an AI algorithm is not going to wreck your process system and cause millions of dollars in damage? Like, what kind of actuarial science is needed for that? Then we have governmental organization and civil society, professional organizations, right? But those are really the other part. And until you have all of these, you really don't have a mature organization or a mature industry. You need all of these things to ensure success and to ensure what I would call resiliency and reliability that's kind of required of our modern life. Next, we want to talk about context. So this is something sometimes people will flip out about and say, well, this AI doesn't need to be explainable. It's not doing anything crazy, or it's not involved with medicine, or it's not flying planes, whatever it is. And you're right. Some of those things can be worse context. But regardless of the circumstance, regardless of the situation that you're working on, if whatever context you're in, you need to understand how it could go wrong. So let's say you're making a recommender engine for selecting a movie, right? This is the Netflix For You thing or whatever. How could that go wrong? Well, I suppose, let's say your algorithm mistakenly inputs a horror movie into a family centric household where they're watching family movies and stuff, and all of a sudden it suggests, The Ring, and a younger child, watches that. It's in that thing. Why would it be bad? Um, and that could be extremely damaging to the child. Also could lead to a very frustrated parent and likely abandonment of your service. I actually have a friend who literally canceled Netflix because of its poor parental controls that he thought. Next, let's say you have an AI diagnostic tool for computer malfunctions. So let's say you have an application on your computer that you can run if your Warzone isn't giving you enough frames or whatever's going on. You can run this tool and it will go through and test memory and kind of explore different things. And how could it go wrong? And what would those impacts be? Is this the most, I would say, safe impact, right? Is that if it was incorrect, it would drive unnecessary repairs, possibly, so waste of money for your customer. Or it could lead to recommendations like, oh, this is what's wrong, delete this file. You delete the file, you brick your motherboard. Or something horrible like that happens, right? There's also a lot of things with that. What if this is the old antivirus problem, right? Of, what if your AI diagnostic tool doesn't think something bad is bad? So it just doesn't give you the recommendation. So if you're over reliant on it, that could be problematic. Next, looking at an AI diagnostic tool for surgery. So could go wrong. How? Now, I put diagnostic tool in here intentionally. So this wouldn't be an AI doing the surgery. This would be some AI that runs diagnostics on surgical equipment. Various, and assuming these would probably be robotic equipment, like the lasers they use for LASIK or something like that. Could it go wrong, and how? And how do you kind of consider that? Well, obviously, if it says this thing works great and it doesn't, that's a malpractice problem, I would guess. But is it? That's the other question. Is the doctor liable for what an AI diagnostic tool that's been approved by some company, what it says? And potentially not. But then the company would likely be. So, what's the impact of that going wrong? Lawsuits, public relations problems, those kind of things. Now, AI-driven flight controls. Could that go wrong? And if so, how? Well, we have recent experience of this. The MCAS system in the Boeing 737 MAX wasn't AI per se, but was algorithmically driven flight controls. And it went very wrong for hundreds of people. So the point of talking about all this is that no AI does not need can get away with minimal user research. Okay, regardless of what it is, you need to test the thing. And you need to have an understanding of its failure modes and how you're going to design for those. And again, that's the only way we're going to get to widespread adoption of these things. You also need an understanding of the human use of AI. I don't know about all of you, but I despise chatbots and that they're on every single website. They were on a website the other day for a local plumber. Why do I need to talk to an AI for a local plumber? I just need a phone number to call the plumber. And that they automatically pop up or will interfere with your browsing. Terrible, terrible design all around. Whoever does this, they should be arrested. I don't know. Recommender engines. We need better understanding of how we use those as humans and what value they have. Decision-making supports. Now, if you ask me, I'd say this is where AI should live. This is where I think it's most valuable. It's something humans won't rely on incredibly often, but can provide that depth if needed. And then super tools. This was a term from Schneiderman's papers, and this talks about essentially, more advanced software or hardware that includes AI as decision-making support or as some automated correction features and things that are minimal but are transparent to the user. And our role is to find out how our users need and expect this stuff to all work and be safe and useful. And we need to understand how can it go wrong, because it will. And yeah, it might just be, oh, no big deal. It suggested a Adam Sandler movie when this person hates Adam Sandler, has never watched one of his movies on that application. It also could be, oh, our algorithm is serving body shaming content to teens and has led to multiple suicides. So as developers, as makers, right, our hands are a part of that, and we need to take that responsibility seriously. Then looking at human performance issues with AI. Sorry, my voice is really rough today. So, what happens when you have an AI that is present in whatever situation? Well, immediately your human's out of the loop. That means the system is operating without humans necessarily interacting with it in some way. So humans therefore have less insight into what's going on. You have complacency problems or vigilance decrement. If we have over-reliance on AI, we'll have more complacency, which isn't a big deal. Again, if you're choosing a movie on Netflix, can be a very big deal if you are trying to ensure that this surgical robot can do its job. We also will get less critical thinking because the AI has been pitched to us that it can do that for us. Under reliance, both have problems. This is an idea that came largely out of, or at least was well captured in Lee and C's 2008 paper on calibrated trust in AI, and how it is very, very important that your user has the proper level of reliance on AI for the context and the technology. How are you going to get that? User research. With less engagement, you get weaker memory pathways. So let's hope that thing you're having AI do 30% of the time, let's hope that losing that 30 doesn't make that worker more faulty in the 70% of the time they have to do it. You also will have massive variations in trust, acceptance, and interpretation across any large scale. Because, and if you're not sure about this, especially if you're like a AI developer or somebody sitting there, ask for people to define trust and how they would know it or what characteristics it has. These are concepts, interpretation, understanding, explanations. These are concepts that we still haven't solved after thousands of years. So the way to get there closest is with early and often user experience research to try to get at those questions. The only way you're going to get close. And also poor localization. An AI that's trained on explicitly English American data may not work at all in a different societal context in a different place in the world. So that's also a huge issue that I don't think is well captured in a lot of AI spaces. A lot of folks aren't talking about that one, but that's a real problem. So how do we fix it? Well, like everything that we've talked about in this, in this course. The solution is an early engagement of design personnel and active user research at kickoff. Human factors, UX, all have the tools to help develop a better AI machine learning solution, as long as research is allowed to be done. Just hiring a UX designer won't do it. And it's been proven over and over and over again that not involving user research costs money, time, and morale. If you have to tell your developers that 30% of their code has to get junked at the end because it doesn't work out in the field with actual users, that's a bummer. Also, it's going to cost you time and money. What about the users that eventually have to use your abomination of a product? That's not great either. And that's kind of the takeaway from all of these videos, is just bring us in. We're cheaper than you think and more valuable than you think. All right, and that's it. And thanks for watching.